Hello everyone. So welcome to the next lecture. We are analyzing power sector right now. So what we have seen is that power sector had some typical issues that while this is going to be the driver for world net zero energy transition, what we had also seen was that it has challenges with respect to assets locked in. It has issues with respect to huge capital cost requirement. It has issues with respect to renewable energy integration, which brings in challenges with respect to storage as well as grid. And on top of it, what was also seen was that things will move more and more to electricity. So this will also put in more pressure on the whole system altogether. So that was kind of a world scenario. So let us understand what is happening in India while we are talking about the world state scenario. Let us also understand what is happening in India against this. So India is like at one end, India still is coal dominant, but on the other hand, India is much more coal dominant than the world is. Like, so if you just look at emissions from in India, India's emission is primarily in electricity sector is primarily coming from coal. So this is the scenario. So if you look at the emission, it is primarily because of coal and coal and coal only, because of India's dependence currently in terms of the overall electricity production requirement is about 75% of electricity requirement. 75% of electricity is being produced by just one source, which is coal. 75 to 80, depending upon year to year, it kind of varies. But it is in that kind of range. India still is hovering. So emission intensity for India remains much higher compared to the rest of the world. So while this transition has to happen, India has to transition much more aggressively compared to the rest of the world. And that is also very obvious from here is that if you look at carbon emission intensity of India electricity versus the rest of the world electricity emission per kilowatt hour, India is 30% higher with respect to world. With respect to per kilowatt hour, India has much more carbon emission intensity of India is much higher, which shows India needs to work this extra bit to bring, if India has to bring this sector down to net zero emission, and electricity is going to be the key as we have seen the worldwide. So we will also look into this issue much more when we kind of go along to transport sector also. But as you can imagine, what it would also mean is that even EV in India may not look as green as for the rest of the world, because EVs are primarily charged by the grid electricity as of now. And if they are charged by grid electricity and with grid not being green, so that would mean that our EV is really green in India. And that's a very interesting paradigm. But for now, let us stick to power sector. And as you can see that India's power sector is kind of more carbon emission compared to the rest of the world. And then what is happening in India in addition to that? What are the further challenges for India? There is a structural constraint in India further. Like we have been talking about the age of the coal plants. We have been talking about that there is a lock-in phase of that each coal plant which kind of comes in kind of gets locked in by 40 to 50 years. That's a typical life of a coal plant is. And if that is a typical life of coal plant is, then what we need to really see is that what is the current life of the existing plants. So if you then start looking at the average age of these plants, and since India has grown recently and the power demand has grown much more recently, which I showed you in a graph in my last lecture, that both China and India has kind of grown very drastically from 90s onwards, from the time the economy started going up. So average age for India's coal plant is about 13 years as of now. And that was in 2020 data basically. But with that kind of an average age, the lock-in period for India will be much higher for compared to most of the rest of the world. So look at US, we are talking about almost near the end of life. Russia is kind of end of life. Europe maybe 5 to 10 years more. Similarly, South Africa. But look at China and India, and these two are the highest consumption of coal with respect to just the sheer capacity of the coal plants which is available in these two geographies. And with this, India has this challenge of that average plant life is just 13 years as of now. So India has to this kind of strengthens the technology lock-in much more. So if India has to take that call, and if you remember, we were talking about stranded assets, that if we take this high transition bit, then our assets might be stranded, or assets would have to be written off. And we were talking about money in trillion of dollars almost at that point. So you can imagine for a country like India, this bet that India will not you utilize this coal plant beyond a point, will become even tougher. So because average age of these plants is much lower. So that is additional challenge for India going forward. Another challenge for India, which is different from the world, is that India has a structural change in the energy demand growth. India energy demand is reshaped by population growth, income expansion and urbanization. What is happening is that India now is the highest population country. India's population is highest in the world now, and also it will continue to be the highest as per the current predictions which are going on. So just remember KANPUR-NPTEL. So if India is going to be the most populous nation in the world, and it will continue to be most population nation of the world, just by the sheer multiplication of number, India will continue to emit much more, and it will continue to consume more and more power as country grows. So that is one definitive challenge which is India is facing. Now, a second aspect, like remember the second aspect of the entity, GDP per capita. India is one of the fastest growing economy in the world right now. So more than India growth curve is about more than 5% right now. And with India growing at that pace, so it means the spending capacity of people will keep on improving, will keep on increasing. So this is the second aspect of the entity. Also becomes much tougher for India, because the first aspect, population is growing, GDP per capita is also growing very fast. So these two aspects put together puts a huge pressure on carbon intensity and energy intensity as to other verticals of entity if India has to move towards a more carbon neutral thing. A power sector is being what it is for India's carbon footprint also. You can understand that India's carbon footprint would get highly impacted by these two factors growing this rapidly. Third thing which is happening is that urbanization in last 500 years also is increasing a lot. So India was not because India was under the British rules for such a long time, and that growth was not happening. After the growth has started happening, look at the growth curve of India. Like, so China grew very fast because of the economic development started there faster, but now India has started catching up that thing pretty quickly. Japan, US, they are kind of saturating right now. So look at Japan, it is saturating. US, it is saturating, but India is on the highest high growth curve. So what will happen is that, and with more urbanization coming in, there are definitive data around it, and which I have showed you earlier in one of my earlier lectures, that with more urbanization happening, the power consumption goes up, the energy consumption goes up. So all these factors are kind of playing against India when it comes to energy transition pathways. Further, what is happening in India is that now energy is, or the power is getting converted from, like India is now moving away from energy excess as an energy as a service model. So India used to be underlit country till not very recently, and India used to be half lit or maybe partially lit. A lot of part of India was not connected. India was not fully electrified and all those things. But when we have crossed that phase, now India is moving towards the next phase of the growth, which is the energy service phase. So earlier focus used to be just lighting, cooking, basic electrification used to be the focus. Now transition is happening towards comfort, mobility, productivity, digitalization. Look at the growth of mobile phones and look at the growth of the digital infrastructure which has built up in India of last few years. So households are increasingly demand for high thermal comfort, appliances, transports are increasing as the dispensing money is increasing for people. So energy is getting more and more consumed per household also. So per capita energy consumption of India is also going up drastically, because as of now, India is less than the world average with respect to electricity consumption per person. So India is less than that. So while India is growing, India first will run up and be in line with the world averages. So what we are seeing very clearly is that India has this another challenge of this energy becoming as services. Just look at the IEA data, one of the IEA data for future of cooling. What IEA says is that India is currently is, with respect to cooling, India is highly underrated country as of now. India's cooling per person is very low compared to the rest of the world. So look at Japan, look at US, look at Korea. So with more dispensable money coming in pocket of people, this service will be demanded more and more by people. So India is even lower than South Africa, Indonesia, and many other developing nations also when it comes to current cooling deployment. Look at this data further. So, and what is happening is that climate stress is happening, and climate stress is happening is increasing temperature. With number of hotter days going up, and with health and productivity has to be maintained for people working in indoor environment. So that kind of brings a need for having more indoor cooling needs more and more. So this, along with the other aspects where we have seen that urbanization is increasing, population is increasing, GDP per capita is increasing, and with all that increasing and with the environmental challenge also coming in, India is bound to move towards higher and higher cooling needs. Like if you look at current India's data, if you look at per capita income, while people who are well-to-do or have a higher per capita income, they are using these services almost like a world average, or maybe sometimes slightly lesser, or maybe almost in tune of that. But refrigeration is almost at the 100% houses in urban, while it is at or while in for lower strata people this is about a 60% houses. But look at ACs. Only about 40% of Indian houses which are in the higher strata of money have ACs, while lower strata of people in India hardly have air conditioning, hardly have even fan also at times. So this is not a sustainable model, and based on this there has been research around it. So as per this research, the current AC ownership in India is about 8%, but which is rising very rapidly, and it is expected to grow to about 40% in next 2 decades. So just imagine the number of people that will get multiplied with respect to number of AC being used. Number of ACs will increase so drastically in next 2 decades that itself sheer volume of these ACs coming in, sheer volume of these cooling needs coming in would put so much of pressure on national grid, along with this all over transition, and along with the transition which has to happen. Our grid will be under huge challenge of this exponential growth which is expected to come in the sector. And it is not only the urbanization, but even the rural sector also, which has been a non-participant in this thing of air condition so far. They are also expected to start participating in this phenomena in next couple of years. And with the more dispensable income coming in rural India also, with temperature rising so fast, this need for cooling indoor places will rise drastically. So this is definitely going to put pressure on Indian system. So while cooling matters, is that although cooling is only just one service, but it outsizes the system impact, because each air condition would mean huge power consumption, almost like 1 to 1.5 unit per ACs per hour kind of a thing that we are talking about. And it unfortunately it coincides with afternoon grid peaks, when industrial power consumption is at the highest number. This thing can also coincide with that. Not only that, for domestic thing also, like when people reach home in the evening, like there is another peak which kind of comes in domestic Indian consumption, which is an evening peak, and that evening peak is primarily happening because of this AC load, which is kind of sets in when people reach home. And what this rapid AC adoption will do is it will drive the capacity expansion requirement. And the issue is that this will all get logged in around the peak power requirement. And with this peak power requirement, if we have to avoid tripping, then infrastructure has to support this peak requirement which is expected to come. So this, what it will do is that it will force India to build in those capacities to meet this expected peak requirement. And with this expected increase in the peak requirement getting locked in at such a high value, this will put pressure on Indian grid system more and more. So distribution network will face localized overloads, and there could be tripping issues, there could be issues. So that's where our grid network needs to be that much stronger. So overall, what is expected is space cooling demand projected to rise nearly 15-fold by 2050. Overall, if you start putting this number, like moving from 8% to 40%. So, and along with the longer hours which is expected to come in all put together. So if this is one of the data by IEA, that energy used for space cooling, if you look at India with respect to 2016 versus 2050, India might be one of the highest energy used for space cooling, even outnumbering China, even outnumbering US in some cases. So that's a huge requirement. India might be one of the highest energy consumption place with respect to the space cooling requirement, and which, as you can imagine, will put huge pressure on the overall energy requirement which India will have. In fact, India has kind of doubled its electricity generation in last about 10 years, but it is expected it will have to kind of keep growing at a very rapid pace in coming years also, if it has to meet these requirements. Right. So, this development-led demand growth creates a planning challenge, because India's challenge is not simply about supplying more electricity, it is about managing development-driven demand intelligently, because population plus income plus urbanization plus cooling needs, it is driving the baseline growth. And climate change is also accelerating the thermal needs. So, cooling is one of the high impact parameters. So, if we don't do the early intervention, if we don't look at the model in a more structured way at an early stage, what can happen is that we can be locked in for a long period with inefficient technologies, inefficient infrastructure, which could be really challenging for a country like India, which is still growing as an economy, and with so much of people who are still kind of struggling to meet their end. For them, it will be a further challenge, and it will be a huge risk altogether. But having said that, India has made its NDC commitments, and India says that it will reduce its energy intensity of GDP by 45% by 2030 compared to 2005. So, what India is simply saying is that how much of energy does it need per unit of GDP in 2005 compared to that energy per GDP in 2030, that will be a 45% reduction in that. What it is also committing is 50% of installed electricity capacity will be from non-fossil fuel based source, where India is betting big on things like solar, and also so solar primarily, and also wind and everything. So, overall India is targeting to have a capacity of 500 gigawatt from non-fossil fuel based sources. Out of that, just 280 gigawatt is expected to come from solar. That's what India is gunning for, and India is targeting to go in that line. It is also working on climate finances and technology transfer as one of the verticals for this thing. And also it has kind of a other program also, where it is trying to involve the bigger pool of population through initiatives like LIFE and those kind of initiatives, where behavioral level interventions is being talked about by India a lot. You remember we were talking about behavioral intervention to be 8% responsible for overall transition in this net zero journey. So, India is betting big on that, because that will require very less amount of money. So, India is trying to bet on that, so that India can utilize this specific vertical to meet its other growth challenges. Based on this, and based on some other data, there has been some modeling which has been done by some other research groups in India. So, this is one of that paper which Niti Aayog in India has put on their website. So, they have kind of made 4 pathways for India's potential transition to net zero energy. As you can see that India's energy growth is expected to grow in almost all scenarios. India's energy growth is expected to grow in all scenarios, because India is still growing, as we talked about. So, what they have done is that for them they have developed 4 paths. NZ1 is primarily a nuclear driven path, where they are betting big on nuclear, that if India makes a transition towards nuclear side, nuclear is the main source of energy. And what will be the transition path for that? What will be how much of electricity would be needed to kind of meet India's needs and stuff like that. And the second path they are talking about is fossil fuel based. They are saying that fossil fuel may not be written off completely, and this path has been developed keeping fossil fuel is still as the core of India's transition, because they say that if fossil fuel may not go away by 2015 India, because India is highly dependent on fossil fuel as its primary source. So, this pathway has been developed based on that. Third pathway has been developed with renewables being the prime source. Like here, while nuclear was the prime source, here nuclear is kind of a supporting thing, but more emphasis has been put on renewables as a primary source. And the fourth transition is where they've kind of gone into a more multiple pathways for this optimization model, and in that again renewable is coming as a major source of energy compared to other sources of energy. So, a lot of emphasis has been put on efficiency here. So, that's why you see the net energy requirement here to be lower. So, I'll encourage you to read this report, whoever is interested to kind of go more on this. But each pathway produces different emission trajectory. Obviously, as you can imagine, the fossil fuel based path has highest emission, and the rest of the paths will kind of have its peak, and then it starts going down, because they will have peak around when the emission kind of keeps on increasing, because the demand is still increasing. And this technology cut-in will start having its impact beyond a point only. And once you start doing that, what they've seen is that all these paths will lead to much lower emission compared to the emissions which you will have currently. or which is expected to peak around 2030 in all these models, but it will have emissions of almost 1/6 or 1/7 compared to what is expected to happen in 2030 in almost all scenarios, of course, but fossil fuel based scenario kind of remaining still high at innovate. Rest all scenario kind of converges by 2070, but following a different trajectory. In terms of capital requirement also is, so currently India's cost per unit is about 5 rupees per at a generation level. And how the path has been made is that all these paths kind of look like that they are much more cost effective with technology cost coming down. One of the constraints which is put in this model was the cost should be lower than the current cost. So with this, the emission has, so with this, the cost has been kind of taken into account and kind of worked around that thing. And along with that, emission intensity has been also kind of pictured here. And with emission intensity, it is very clearly that emission intensity also is much lower compared to the current emission intensity, which is about 765 grams per kilowatt hour. So, other paths are showing much lesser emission intensity. And that kind of leads to this kind of a path which is shown here. Investment needs are also varying from path to path, and obviously nuclear based path is shown to be the best route from that perspective, but obviously it has definitely challenge with respect to its safety issues and all the other aspects. The highest is when all the emphasis has been put on renewables, though that specific path is very promising when it comes to emission and with respect to energy security and all those aspects, but probably the capital requirement there will be the highest. But since Indian corporate has been participating in this transition a lot, so this may be a much safer bet compared to other path, because this is not so much of government money dependent, but maybe private corporate dependent, though the government also gives some subsidies around it. And this is the mixed emission path which is kind of sitting at the middle somewhere. So this report kind of gives multiple scenarios in terms of how India can make this transition, how this transition can happen for India in various forms and shape, what could be the trade-offs, how much would be the emission, how much will be the various capacities which will be required in various scenarios, right? So with this in mind and with NDC target of India being in mind, India has launched multiple schemes also. National Solar Mission is, people have been talking about PM Surya Ghar Yojana, or where rooftop solar is being talked a lot about this scheme, and government is pushing for this scheme more and more because of the real estate issue. Because if you start putting solar panels on the ground, you are basically covering some ground which can be utilized for some other means and for other utilizations. To avoid that, rooftop is being pushed as one of the very aggressive schemes by Government of India, where they are trying to also reduce the load on grid also, because they think that once more and more rooftops have solar, so it would mean that pressure on the grid also will go down, because then homes can work in an off-grid mode more and more. But obviously this scheme has some challenges with respect to the cost, because the cost of solar is higher in this case, because economies of scale cannot be arrived in these cases. But for a general consumer, it may be very interesting, and government is looking at from that side that they may need to put less money on the grid side of it. Another scheme which government is talking a lot these days is PM Kusum Yojana, which is about solar based water pumping for villages, and also converting the village fields and village houses into a power generation sources. Again, a real estate kind of a work, and plus off-grid kind of a phenomena which is being worked out here. This scheme has not been so successful so far, but government is now putting lot more emphasis on this scheme of late, and it has kind of shown some kind of a flip over, and it is now started to getting adopted more and more, though it's had some other challenges with respect to water table and all those things, but that's a separate discussion altogether. Green energy corridors are being now pushed by government, where government is trying to create these green energy corridors, talking about creating this storage capacities, creating this stable grid, so that more and more green energy can be pushed through the system. Renewable purchase and energy storage obligations are being also pushed into system. Lot of tenders these days are coming with RTC mode, with round the clock kind of, even renewable energy tenders are coming with more RTC requirement. The specific developer has to give a round the clock kind of a guarantee to push this in the system or to get the tender, and where they have to work in with respect to 80% in some cases energy reliability, or some in cases 90% energy reliability. That kind of a system is being pushed in more and more in the recent tenders about it. And then also on top of it, government is given the grid would be the prime source of this energy carrier. There is a national smart grid mission also, which is kind of running in parallel, and India talk about one nation, one grid kind of a phenomena, where the whole of the grid is integrated grid for India. And India is now talking about a smart grid kind of a phenomena, which can then handle this varying load of renewable energy integration and other sources. So overall, India is trying to put all this its vertical together, and they're trying to kind of put the whole picture together to make this transition as smooth as possible. Just to summarize, India sees that electricity demand must increase to support development. That is a very, very obvious and given thing. Even if you see India's transition model also, it is very obvious that India will face this challenge. India carbon intensity must decrease to meet climate goals, because as we see that India is about 30% more carbon intensive compared to the rest of the world. So that has to go down, and that obviously a very aggressive transition plan has to be made on those lines. And obviously these two processes must occur simultaneously, and that is what the challenge India is facing. And this tension is basically defines India's net zero challenge, because, and that's why India is not committing to become net zero by 2050, but more like 2070, because India do not see a very short term path for it to balance both the aspects with respect to this growth management as well as the renewable energy transition management, and then also managing coal plant lives also. So these are multiple axes which India is kind of struggling with, and India is kind of trying to manage everything in parallel. While the world is moving at a different pace, India is moving at a different pace because of all these verticals being managed differently. But just to summarize, power sector from a global perspective, the power sector is a rate limiting step for net zero. That is the sector which is being talked about being the highest emitter on one hand, and also as the world get electrified. So this sector is projected to be the key sector for the whole net zero transition for the world. The failure to decarbonize electricity sector will constrain every other sector, be it be transport, be it be building, be it be industry. We'll talk about industry from the next lecture onward, but we will see that everything depends upon this green electricity transition, and more electricity, and then electricity has to come from green energy sources. This is a kind of a given around which world is betting on, and if that doesn't happen, world would be struggling to become decarbonized. Right? So, but success on this will enable economy-wide decarbonization. That is what is expected. So overall, this sector is a very, very interesting sector, because on one hand, this is the biggest culprit with respect to carbon emission, but on the other hand, it looks to be the biggest savior also, potential savior also of this carbon emission. So I've tried to kind of give you overall picture with respect to the global issues and with respect to the Indian issues also, what are the challenges, what is being done, what kind of money are we talking about in terms of all of this transition, and how the interplay of various axes is kind of playing a role and making this transition a very interesting space to be in. Thank you, and from the next class we will start looking into industrial sector and then move to transport and then building and agriculture in kind of that sequence. Thank you.